Hello everyone. Today I would like to discuss about rotational motion of a rigid body about a fixed axis. So first we have to choose some rectangular coordinate system to understand this rotation about a fixed axis. This red pen taken as x-axis, this gray pen taken as y-axis, and this blue pen taken as z-axis. So the horizontal plane is the xy plane. Let us take, this is a rigid body which is placed in xy plane, or we can take any extended object also. Not only this, any extended object which placed like this. It has some x coordinates. It's like, looks like some extended body. Okay, if you want to discuss the rotation motion about a fixed axis, so take z-axis as the fixed axis. For suppose this type of force is acting on it, this type of force, this force has two coordinates, one is x coordinate, another one is y coordinate, and it can rotate this object about this z-axis. So the torque due to this force, that is r bar cross f bar, it is along z-axis. R bar cross f bar, it is along z-axis. So the torque due to this force is along rotational axis. That means when the force lies in plane perpendicular to the axis of rotation, the torque is along rotational axis. And if the force is also parallel to the rotational axis like this, it rotates the object about the y-axis. Like this, about y-axis. So there is a change in rotational axis. So we should consider, when we talk about a rotational motion, a force or a component of force that should be lies in the plane perpendicular to the axis of rotation. When we talk about the torque due to a component or a force which is parallel to the rotational axis, need not to be taken into account. This is the first condition to obtain the rotational motion about a fixed axis. That is, we need to consider only those forces that are lie in the planes perpendicular to the axis. The forces which are parallel to the axis will give torque perpendicular to the axis and need not to be taken into account. So that is, when a force or a component of force parallel to the rotational axis, it changes the axis of rotation either z to x or y depending on the force. It is depending on the situation. For this case, when the force is a component or a force that is parallel to the axis of rotation, this can it has a tendency to rotate the object about y-axis. So there is a change in rotational axis. So we should not consider the torque due to this force. When a force lies in xy plane, it has a tendency to rotate the object about z-axis. So that we have to consider such a force to calculate the torque. So this is the first condition we have to consider for obtain the rotational motion about fixed axis. There is another one. For example, we need to consider only these components of position vector which are perpendicular to the axis of rotation. The components of position vector along the axis of rotation will result in torque perpendicular to the axis and need not to be taken into account. For example, this is this is the rigid body lies like this, x-axis, y-axis and z-axis like this. It has a two, it is lies in yz plane for this particle. When a force acting on it, the component that is the components which are perpendicular to this axis, that is along x-axis. For example, this type of force which is acting on it along y-axis, the force is along y-axis, the torque R bar cross F bar. So there are two lever arms for this force, one is along x-axis, one is along y-axis. When we take along x-axis, x bar dot y x cap bar y cap, that is a force direction that gives z direction. So the torque along axis of rotation. So there is no change in axis of rotation while the object is rotating. When we take the component of this position vector of the particle along z axis, when we take the torque due to this force, that is y cap direction, and the position vector z cap does z cap bar y cap, it gives along negative x axis. There is a change in z cap. Okay, there is a change in rotational axis. So we must consider the position vector component is the position vector always perpendicular to axis of rotation. Thank you.